This video goes through the skeleton note 1.3, measures of dispersion. So we looked at measures of central tendency, and now we're going to look at measures of dispersion to describe the spread of the data around a central value. The values that we looked at before just tells us where the middle of a data set lies. So a couple different qualifiers that you need to be comfortable with. One is the range, the difference between the largest and smallest values. Two is the quartiles. They separate the original set of data into 4 equal parts. The first quartile is the value of the way, 1/4 of the way into the data. And then the second quartile is actually the median of the data. The third quartile is the value 3/4 of the way into the data. Okay, you can think of the Q1 value as the median of the lower half, and the Q3 value as the median of the upper half. The final term is the interquartile range, which is the difference between the third and first quartiles. It's also called the middle half. So one way to demonstrate the spread of a set of data is to use a box and whisker plot, which is a 5 statistical summary. They all look like this here. Your minimum value is over here on the left. Your maximum value is over here on the right. This first part of the box represents your first quartile. Your median is in the middle, and your third quartile is at the end of the box. The length of the box is your interquartile range. Your length from minimum to maximum is your range of the data. And then these two little pieces here are called your whiskers. Another piece of terminology that you should be familiar with, it's also a good IB exam question because it's sort of an interesting fact here. Outliers represent extreme or distant data, and an outlier is any value at least 1.5 times the interquartile range above Q3 or below Q2. So for example, if our interquartile range equals 10, to check for sort of the minimum value for an outlier, we would do Q1 equals 2 minus 1.5 times 10. And Q3 would start with, let's say, 12, and we would add 1.5 times 10. So that's 15. So if you had a value in your data set above 27, that would be considered an outlier, or a value below -13. Okay, so let's do an example where we're actually finding some of this information. So in example 1, we're looking for the range, the median, the lower quartile, the upper quartile, and the interquartile range of these class marks here. So the range is usually the easiest. You're going to take the biggest number, take away the smallest number, which gives you 47. Okay. The median, also fairly straightforward. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So our median is going to be in between those two seventh groups. So 1, 2, 3, 4, 5, 6, 7. So right here. So our median would be 62. plus 65 divided by 2, which is 63.5. Our lower quartile would be halfway, so the median of this bottom set here. So we've got 7 numbers in there, so this would be our middle value of the bottom set. And then we can do the same thing for our upper set here of data. So again, our middle value right here, so Q3 is going to be 70, and then now we're looking for our interquartile range, which is just the difference between those two, which is going to give us 20. That would be the width of our box. So now what I am going to ask you to do is to draw a box and whisker plot. Let's see if I can copy these values so I have them here. Oh, look at that. Cool. Okay, so I'm just going to put this down here. This is our data set from example 1. There. Okay, so using the statistics found in example 1, we're going to draw a box and whisker plot. So it doesn't really matter where it goes on the y-axis. You want to label your x-axis. I'm going to go by 5s here. 30, 35, 40, 45, 50, 55, 60, 65. Just like you would if you were drawing a graph of a parabola or any other function, you want to choose values that make sense so that it's easy to plot. So I'm going to start with my Q1 value, which is 50, and I'm going to draw a line right there. I'm going to put it right about here. And then I'm going to do my Q3 value, which is 70. That gives me the outside of my box. So I'll fill that in there. Now I know that my maximum value is 80. So I'll put a bar right here and a whisker between those two. And I know that my minimum value is 33. So that's probably somewhere here. And I'll go like this. And then I have my minimum, my Q1, Q3, can't forget about Q2, which is my median, so 63.5 here-ish. Okay. The next thing that we're going to check is if 33 is an outlier based on the data set from example 1. So what we need to check is if 33 is more than Q1 minus 1.5 times the interquartile range. So that's what we're checking, is 33 greater than 1.5 times the IQR below Q1. So in order to do that, we've got 1.5 times our IQR, so that's 1.5 times 20, which is 30. And then the second thing that we're going to do is Q1 take away 30. So Q1 is 50, take away 30 would be 20. Okay, 33 is greater than 20. Therefore, 33 is not an outlier. This next slide shows the GDC steps. There are some good emulators if you don't have a graphing calculator yet. On Android, there's one called Wabbit Emu. And on iPhone, I think it's called Calculate 84. But those are two free emulators that you can get for a graphing calculator on your phone, because you are able to use that as a tool on your graphing calculator exam. So I'll link a screen capture so you can see the steps on there. The last example here is, oh, there it is listed again, just matching each histogram to the box plot that represents the same data set. Okay. So let's take a look at, well, let's do this one first here. So A looks like it's got a lot of data values sorted to the right-hand side, which means that our box on our box and whisker plot is going to be over on the right-hand side. So that's going to put us right here with number 3. Okay. If we look at B next, we've got kind of the opposite. It's on the left side. Okay. And our data spread is pretty wide. So that's going to be right here. Okay. Because we can see that because we've got this extra part over here, which is kind of represented by these little X's, which show those outliers far over there. Okay. The next one here, so C, we're going to do next. This has a wide spread of data with the median probably in between 1 and 2. So we've got this next one here, 4. And then the last one is a normal looking distribution or a bell-shaped curve, and that matches with this one right here. So here are the work assignment to practice the concepts in this lesson.